So our first two examples for our 10.2 Simplifying Radical Expressions Day 1 is two examples like what we did last week. So we are just simplifying the number under the square root. So in our example 1, there is nothing outside of our square root, so we're just dealing with the number underneath. So I think to myself, what multiplies to give me 200? Well, it's even, so 2 and 100. All right, I cannot break 2 down into anything but 2 and 1, so that won't be helpful. But I can break down 100. So there's a few ways you can do that. Maybe the most obvious thing that multiplies to give you 100 is 10 and 10. If you broke it down into 2 and 50, you would continue breaking down the 50 and you would eventually end up with the same pairs as me. So I have a pair of 10s. So I can take the 10 out of the square root. So if I take out the 10, the only thing left without a pair is the 2, so it has to stay underneath the square root. Okay, on example 2, we have this number outside the square root that we need to keep in mind before we get our final answer. So we think, what multiplies to give us 54? So we probably are thinking 9 and 6. Okay, and if I think about what multiplies to give me 9, I would probably choose 3 and 3, and there is my first pair. Okay, I could multiply 2 times 3 to get 6, but that does not give me any more pairs, so I'm just going to leave it at the 6. All right, so we need to keep in mind this negative 3 that was already out in front. So I have this negative 3 that I already had outside, and I'm pulling out the 3 from my pair here. Remember, things on the outside we multiplied together, so I'm going to have a negative 3 times 3 on the outside, and then my 6 did not have any pairs, so it has to stay underneath the square root. So now I would multiply the two outside terms together. Negative 3 times 3 would give me negative 9, and we have the square root of 6. All right, so now that we have a pretty good hang of how to simplify our square roots with numbers, we are now going to talk about what happens when we have variables underneath our square root. So we're going to kind of think of this the same way that we did when it was just numbers. What multiplies to give us what we have underneath that square root? So underneath our square root on number 1, we have a squared. So if I'm trying to think about what would multiply to give me a squared, well, when you square something, that's multiplying it times itself. So a times a is the same thing as a squared, right? So this broke down into a and a. And look, we have a pair. That means it can come out of the square root. So the square root of a squared is just a. All right. On number 2, we have a cubed. That would mean a times itself 3 times. So I have a times a times a. Now remember, when you're looking for things that you can pull out of the square root, we can only do pairs, which means 2. So I can put 2 of these together and I can pull them out of the square root, but I am going to have 1 left over. So I can take 1a out, but this one has to stay underneath the square root because it did not have a pair. So the square root of a cubed is a square root of a. All right. On number 3, underneath our square root, we have a to the 4th, which just means a times itself 4 times. A times a times a times a. And again, remember, we're looking for pairs, so groups of 2. I have 1 pair here and another pair here. So that means I get to pull them both out from underneath. So I get to pull out 1a and another a. Now remember, just like here, if you pull out more than one thing or if you have more than one thing outside of your square root, we multiply them together. So I'm going to have a times a. And remember, when you multiply variables, you add their exponents. Well, there's not one written, but it is an understood 1. 1 plus 1 is 2. So the square root of a to the 4th is a squared. All right. On number 4, we have the square root of a to the 5th. So a times itself 5 times. So we have a times a times a times a times a. And we are looking for pairs. So I have one pair, another pair, and then we have this one left over here on the end. So I get to take out 2 a's. So I'm going to have a times a, which over here we said would give us a squared. But then we do have this a left over, so it stays underneath the square root. All right, on number 5, we have a to the 6th. So a times itself 6 times. A times a times a times a times a times a. And we circle our pairs. So I've got 1 pair, 2 pairs, 3 pairs. So that means I get to pull out 3 a's. Now remember, when we multiply variables, we add their exponents. All of these have an understood exponent of 1. 1 plus 1 plus 1 is 3. So I have a to the 3rd. So the square root of a to the 6th is a to the 3rd. All right, last one in this section, we have a to the 7th. So a times itself 7 times. How many is that? 1, 2, 3, 4, 5, 6. One more. And we circle our pairs. So I've got 1 pair, 2 pairs, 3 pairs, and a leftover. So we get to pull out 3 a's. So we have our a to the 3rd, and then we have an a leftover that has to stay underneath the square root because it did not have a pair. So then they ask if we see a pattern in examples 1 through 6. So we have 2 types of answers here. We either had an a to some power all by itself, like on numbers 1, 3, and 5, or we had some a to some power with a square root tagged on the end, like numbers 2, 4, and 6. So we notice that 1, 3, and 5 have something in common. If we look at those exponents, 2, 4, and 6, they are all even powers. So we're probably going to have something for the even powers and something for the odd. So for those even powers, like we noticed, there was never anything left over, right? So if we had a squared, we ended up with a. If we had a to the 4th, we ended up with a squared. If we had a to the 6th, we ended up with a cubed. So what we might notice is what the exponents were and what they became. So this was 2, it became an understood 1. This was 4, and it became 2. This was 6, and it became 3. So what we might notice is that the exponent was halved or divided by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 3 is 2. So if we divide by 2 to take the square root, we will not have any left over, or none remain inside the square root. All right, now let's talk about our odd powers. All right, so my odds were on numbers 2, 4, and 6. So this one was 3, we did have a leftover. 5, we had a leftover. Or 7, and we had a leftover, or something remaining inside the square root. And these are not quite half of what was underneath the square root, because underneath the square root, we had 3, 5, and 7, which are all odd numbers, and there is no half of an odd number. So what we can do here is subtract 1 from the power, then divide by 2, and you will have 1 remain inside. All right, so let's give these 2 rules that we just came up with a try on this next set of examples. All right, so let's start with number 7. So my power on number 7 is 24. 24 is an even number, so this one is even. So I'm going to use the first rule. The first rule says all we're going to do is divide that power by 2, and there won't be anything left under the square root. So my power is 24, and I divide it by 2. 24 divided by 2 is 12. So I'm going to have a to the 12th and nothing left under the square root. All right, on number 8, my power is 31, which is odd. So we're going to use our second rule here. Our second rule says to subtract 1 from that power. So I'm going to have 31 minus 1, which gives us 30. Then it says to divide that by 2. So now I'm going to divide my answer by 2, and I get 15. So I'm going to have a to the 15th, but it also says we are going to have 1a that remains inside the square root, just like we did on examples 2, 4, and 6 up here. All right, number 9, my exponent is a 40, which is even. So we use rule number 1, which is just to divide by 2. So I'll have 40 divided by 2, which is 20. Since it's even, there's nothing left inside, so my answer is just a to the 20th power. Okay, now I'm going to try number 10. My exponent is 47, so this one is odd. So following my rule for odd, I subtract 1. So I'll have 47 minus 1, which gives us 46. After we subtract 1, it says we then divide by 2. So 46 divided by 2 would give me 23. And the rule says that we should have 1 remain underneath the square root. So I'm going to have a to the 23rd power and 1 remaining under the square root or inside the square root. All right, number 11. 120 is an even number. So for our evens, all we have to do is divide by 2. And 120 divided by 2 is 60. So I'm going to end up with a to the 60 and nothing remaining. Last one in this section, 101 is odd. So if I use the odd rule, I first subtract 1, which is going to give us 100, and then divide by 2. 100 divided by 2 is 50. So I'm going to have a to the 50th power, and I'm going to have 1 left under the square root. So this came in handy, these two rules did, when we had exponents that were so big. We would not want to write out a times itself 120 times and then try and circle all the pairs, right? That would take forever. So that's why we're going to use these two rules for our variables under the square root. All right, let's look at examples 13 and 14. So these ones have numbers as well as variables. So we're going to combine what we did in our lesson from last week and what we just learned today for variables. So we're still going to deal with our numbers the same way. So we think, what multiplies to give us 144? This one actually has a perfect square root, 12 and 12. So I have a pair of 12, so I'm going to get to take that out of the square root. For my y, my variable, the exponent is a 2, which is even. So for y, my exponent of 2, all I'm supposed to do if it is even is divide by 2. And 2 divided by 2 is just 1. All right, so I get to pull out the 12 from the pairs. And I get to pull out y with an exponent of 1. You do not have to put an exponent of 1. It's understood, so you don't have to put that there. So we would just have 12y for our answer. All right, number 14. So we've got 81 for our number. 81 also has a perfect square root of 9. So I have my pair of 9s I'm going to get to pull out. All right, for a, our exponent is 4, which is even. So that means all I need to do is divide by 2, and we get 2. For b, my exponent is also even. So I have an exponent of 6. We just divide by 2, and we get 3. And then c, also even. I take my exponent of 10 and divide by 2, and we get 5. So I get to pull out the 9 because it had a pair. And I'm pulling out an a with an exponent of 2, no leftovers because it's even. I get to pull out b that we found is going to have an exponent of 3, no leftovers because it was even. And I get to pull out a c with an exponent of 5, no leftovers because c was even. So my final answer would be 9a squared plus or times b cubed times c to the 5th. Okay, number 15. We are going to take care of our number first. So if we are trying to think of what multiplies to give us 24, we might use 2 and 12. And what multiplies to give us 12? 3 and 4. And what multiplies to give us 4? 2 and 2. So we have now broken these down as much as we possibly can. I circle my 2's. So those get to come out of the square root. And then we have this 2 and 3 left over with no pairs. So they have to stay under the square root. So I get to pull out my pair of 2's, but underneath this square root, I still have a 2 and a 3. I have to multiply them back together. So I'm going to end up with 2 square root of 6. All right. Then we also have to deal with the x value. So my x has an exponent of 5. So 5 is an odd number. Our rule for odds is to take that exponent and subtract 1. 5 minus 1 would give me 4. And then we divide by 2. 4 divided by 2 would give us 2. So I'm going to have x squared that I can pull out, but because it was odd, we should also have an x left over underneath the square root. So here would be my final answer for number 15, 2x squared times the square root of 6x. All right, number 16. First, we would deal with our number. So what multiplies to give us 75, 25, and 3? All right, what multiplies to give me 25, 5, and 5? So there's my pair with a 3 left over. So I get to take the 5 out of the square root, but I am going to have a 3 left over under there. All right, now I'm going to deal with my variables. So x first. X has an exponent of 2, which is even. For even exponents, all we do is divide by 2. 2 divided by 2 is just 1. So I'm going to have an x to the first. No need to actually write the first power. And no leftovers because it was even. For y, my power is 3, which is odd. So our rule for odd values is to subtract 1, which would give us 2, and then divide by 2. 2 divided by 2 is 1, so I do get to pull out 1y. However, because it was odd, we also have to leave 1 remaining under the square root. So my final answer for number 16 is 5xy times the square root of 3y. All right. For number 17, we first deal with the 128. So it's even, so it definitely is divisible by 2. 2 times 64 is what gives us 128. And we should know that 8 times 8 gives us 64. There's a pair. So we are going to get to pull out an 8, but we're going to have to leave the 2 behind. Also, notice we have a negative out in front. That's just like having a negative 1 out there. So I already have a negative 1, and I've just decided that I can pull out an 8. So since there was already a negative 1 out there and I'm pulling out an 8, I'm going to have to multiply those two values together. All right, and then underneath the square root, we have this leftover 2. All right, now we have to deal with our variables. So there are no exponents written here, so they are understood ones. 1 is an odd number. So for A, we have an odd. For odds, we are supposed to subtract 1. 1 minus 1 gives us 0. And then divide by 2. 0 divided by 2 is 0. So we will not be able to take out any A's. But because it was odd, we do have to leave 1 remaining under the square root. All right, then we have to do the same for our B. B, also odd, a value of 1. We subtract 1 and get 0. 0 divided by 2 is 0. So again, we can't pull any out, but since it was odd, we do have to leave 1 under the square root. So the only simplifying I need to do now is to multiply negative 1 times 8, which is going to give us negative 8. And then we have the square root of 2 times AB. All right, last one, number 18. We're going to break down that 32 first. So we probably would choose 8 and 4. We can break 8 down into 2 and 4. I can circle my pair here. So I'm going to get to pull out a 4. And there was already a 3 out in front. So that's something we need to keep in mind. So there's already this 3a squared out in front. And I've just decided I'm going to pull out a 4 as well. Now, there is a 2 here, but it does not have a pair, so it's going to have to stay underneath the square root. All right, now we're going to deal with our variables. So for A, My exponent is 13, which is odd. So for our odd rule, we subtract 1, which is going to give us 12. And we divide by 2, which is going to give us 6. So I get to pull out an a to the 6th. But because it was odd, we also have to leave 1 under the square root. All right, then we have to deal with our b value. So our b is even. Our number is 14. So since it's even, all we have to do is divide by 2. 14 divided by 2 is 7. So I get to pull out a b to the 7th. And because it was even, there is nothing left under the square root. So now we have to simplify. This was already out. Here is what we pulled out. We have to multiply those things together. So we're going to do the numbers first. So I have 3 times 4, which is 12. And then we deal with the variables. Remember, when you multiply variables, add their exponents. Keep that rule in mind. So for a, we're multiplying a times a, we're going to add their exponents. 2 plus 6 is 8. So I'll have a to the 8th. And this is the only b. So we have b to the 7th. And then we still have our square root of 2a for our final answer.